1.6 solid linear inequalities. Puts at least 15 cards for football players. That's an inequality. Inequality is a solution of an inequality of one variable's value that, when substitute for a variable, results in a true statement. The graph of an inequality in one variable consists of all the points on the line that represent solutions. So we need that graph because if you have a situation where you have x is greater, let's say x is greater than or equal to -1. Well, do you really want to list out 0, 1, 2, 3, 4, 5, 6, and so on, plus all the integers, so like 1/2, 2.5, 2.37, pi. You'd have to list all those out if you don't have the graph. So that's the point of linear inequality. So graph needs, it's pretty quick. Usually I'd like to put 2. I just put the number whatever I get in the middle. Maybe put, a couple to the left, or a couple to the right. If it's less than or greater than, then it's an open circle. So x is less than 2, open circle here. And all the numbers to the left make that true. So anything less than 2 makes that true. So 1, 0, 1.5, so on and so forth. If it's greater than or equal to, start at 0, or you got -1, -2. And we got to put a full circle because it's equal to -1, so you put a closed circle in there, and then you have that going to the right because you want all the numbers greater than 1, like 0, 1, 2, 3, or greater than -1. So, pretty simple. Okay, compound inequalities consist of 2 simple inequalities joined by an and or. Okay, so when they put x in the middle, this is what this reads as negative, or x is greater than -1 and x is less than 2. So basically it means that you want numbers between -1 and 2. If x is in between, then you want the numbers between those two numbers. So what you're going to write is, this is what I'm doing, I'm just going to write my 2 points. I got 0, I got -1, I got 2. And they're open circles, so we're going to put an open circle on each, but then we're going to connect them. Okay, because we want numbers between -1 and 2. So 0 would work, 1 would work, 1/2 would work, because those are all the numbers in between -1 and 2. And that's how you'd write that. Now, if it's an or statement, they want numbers either less than or equal to -2 or greater than 1. So start at -2, -1, 0, 1. And -2 is less than or equal to -2, so we want numbers less than that, so we put a closed circle here, we're going to the left. Okay, or x is greater than 1, so we're going to put an open circle here, we're going to go to the right. Okay, so or statements split apart. You can't be less than -2 and greater than 1 at the same time. It's either or, so that's where you get your or statements. Or statements usually split apart. If they put x in the middle, that's an and statement, and they bridge together. Got to practice, work on this on your own. Okay, solving inequalities. Most of this is pretty basic, same as equations. The only thing that messes people up sometimes, and most people are good at by this time, is make sure that if you divide or multiply by a negative, you must flip the sign every single time. When you multiply or divide by a negative, you must flip the inequality sign every single time. Otherwise, you'll have the wrong answer. So make sure you do that. Okay. So you have $50 spent at a county fair. You spend $20 for admission. So just fill that in there. And you want to play a game that costs $1.50. So $1.50 per game. What do you want to make that? We'll just make it X. So $20 plus $1.50 per game. It has to be less than or equal to the number, how much money you have, which is $50. Okay. So we want to subtract 20 from both sides. So we have 1.50x is less than or equal to 30. Then we want to divide by 1.5x, or 1.5. So we get x is less than or equal to, what is that? There we go. 30 divided by 1.5, about 20. Okay, so you can play less than or equal to 20 games. Okay, so you can play 19 games, 18 games, 20 games, but you can't play any more than 20 games. Okay, you really can't play negative games, so it'll be between 0 and 20. If you want to think about it that way, it's got a possible number of times you can play the game, 20. Okay, 20 or less. All right, solve and graph this. Here's the thing about inequalities. When we do equations, I like to keep my x's positive. But when we do inequalities, I like my x to be on the left side because people usually read the x better if it's on the left side to graph it. Sometimes when we get the x on the right side, it confuses them on how to graph it. So I'm going to keep my x on the left side. I'm going to subtract 7x first and get negative 2x plus 2 is greater than negative 4. Then I'm going to subtract 2 from both sides. I get negative 2x is greater than negative 6. Then I'm going to divide by negative 2. So I get x is, when I divide by a negative, I must flip the inequality sign. That's why I put this avoid the errors part right here. So you got to flip the inequality sign to be less than 3. X is less than 3. So we're supposed to graph the solution. We got 3, and maybe we want to put some other points in there. And put an open circle on 3, and anything less than 3 should work. If you plug that in, let's say we pick a number less than 3. Let's pick an easy one, 0. Plug in 0 here and 0 here, we end up with 2 is greater than negative 4 because those are cancel out, which is a true statement. So we know that the test point works. Okay. Got to practice. Make sure you solve and graph these. Okay. Made this real big. Okay. Compound inequality. If they want you to graph this, basically what you do is you do 2 problems at the same time. Okay. You're just going to solve for x in the middle. So you want to add 10, add 10, add 10. So we get 6 is less than 6x is less than or equal to 24. Then we want to divide by 6, divide by 6, divide by 6. And we get 1 is less than x is less than or equal to 4. So that is a compound inequality. That is an and statement. X is between 1 and 4. So that's what we have to graph. So we're going to make a graph. We got 0, 1, 2, 3, 4. 4. And we're going to put an open circle on 1. We're going to put a closed circle on 4. And we're going to connect them because we want all the points in between 1 and 4. If you plugged in 2 into the original one, you plug in 2. 6 times 2 is 12. 12 minus 10 is 2. So you have 10. 2 is less than negative 4. Less than equal to 14. So 2 is greater than negative 4. 2 is less than equal to 14. That checks out. It works. Okay. And not that you have to check it, but I'm just showing you that's what we're looking for is solutions that make the graph true. Okay. Now, for or statement, you just solve these separately, but then you graph them on the same graph. So we're going to solve the left one separately. We're going to have subtract 5. We got 3x is less than or equal to 6. Divide by 2, or 3, divide by 3. We get x is less than or equal to 2. Let's drop down our or statement. We add 7, add 7. We got 5x is greater than or equal to 30. Divide by 5, divide by 5. X is greater than or equal to 6. Okay, so that is a statement. We want x is less than 2 or x is greater than 6. Okay, so we graph that. We got 0, 1, 2, 3, 4, 5, 6. So on 2, it's closed. When the number is less than that, so we go to the left. Okay, or 6 is closed. When the number is bigger than that, so we're going to the right. Let's say I picked a number in between those. Let's say I picked 3. If I pick 3, 3 times 3 is 9. 9 plus 5 is 14. Is 14 less than or equal to 11? No, that does not work. Okay, so 3 doesn't work that well. Let's say we pick 3 for the other one. We got 15 minus 8. Or 5 times 3 is 15. 15 minus 7 is 8. Is 8 greater than or equal to 23? No. Okay, so what makes those true is numbers that are less than or equal to 2 or numbers that are greater than or equal to 6. Okay, write and use compound inequality. A monitor looks at its temperature range from 18 degrees to 34 degrees Celsius. Write the range of temperatures as a compound inequality. Okay, so that's pretty easy. It could be from 18 to 34, so we do the smallest one on the left, 18 is less than or equal to x is less than or equal to 34. Because basically what you want to do is you just want x in between. and x is greater, if you read this the other way, if you read it from x's point of view, x is greater than 18, x is less than 34. So that gives you your range of temperatures. Then it says, then write inequalities in the temperature range in Fahrenheit. So what we got to do is change those numbers to Fahrenheit. Okay, so 18 in Fahrenheit, we have to do 5/9 times 18 minus 32. So 18 minus 32 is negative 20. So it's 5/9 times negative 20. 5/9 times negative 20. That'd be negative 11. Be negative 11.1 repeating. Okay, so that would just take the place of, so negative 11.1 repeating is less than or equal to x, and now we need to change 34 to Fahrenheit. So we'd have 5/9 times 34 minus 32. So it'd be 5/9 times 2, which would equal, no, that's sloppy handwriting. Would be 1.1 repeating. So less than or equal to 1.1 repeating. So it's kind of crazy when you think about it in terms of 8 degrees Celsius versus degrees Fahrenheit, how cold those temperatures are, how crazy they go from one end to the other. Okay? But that's what it would be for Celsius versus Fahrenheit on that. Check that, typo. 18 minus, made a mistake the other day. 18 minus 32 is negative 14. Times that by 5/9. And you get negative 7.7 repeating. So actually this would be negative 7.7 repeating. Okay, so that would be your Celsius temperatures. And this would be your Fahrenheit temperatures. Okay? So that's how you would go about doing it. Got to practice work on those. And your homework's on the bottom. If you have any questions, wait till class, we'll answer that, and that is it.